Hi everyone, my name is Anatole. I'm presenting Project 2 with Karnakti. I'll be talking about reading in the data and doing the Kmeans clustering. So starting with reading in the data, this is pretty similar to what we did in Project 1. We had 3 tables to read in: the learning set, or analog values, the test set is analog values, and the substations. This was done pretty simply. Each value is read in. Each value is either a voltage or an angle. These are combined into a measurements array. Let's take a quick look at that. So this value had an RDF ID, name, time, value, either voltage or angle, substation RF ID, as well as a type. And this is going to be decided in the Kmeans clustering. So this is going to be one of 4 types. So once we've read in all the data, an important part here is combining the voltage and angle. So to do the Kmeans clustering, we're going to look at different data points, and each data point is going to consist of 19 dimensions. So this is a time value, and for each time value there's a voltage and an angle for each of 9 substations. So every substation has 2 values, that's 18 values, and then 1 time point. So every data point is going to be 19 dimensions. I initiate all of the voltages and angles at 1000. That's more for me to just see if everything's being read in correctly. After that, I go through and look at all the time values and find all the unique times. So the time values are going to be repeated for each value, and I just want to find all the unique ones. After that, I go through all of the unique times, and I read in and figure out, based on the name, if it's a voltage or an angle, and for which substation. In this case, it's Clark. Another thing I do is I normalize the values, so I find the maximum and minimum voltage in this case. This is used with find max min method. And to normalize the value both for voltage and angle later on, you basically subtract the minimum value and then divide by the total distance between the minimum and max value. And this gives normalized values from 0 to 1, so that every value in the data point has an equal weight. This is going to help later on when we're finding the Euclidean distances. So for each time value, and I go and I find the other 18 dimensions, and once everything's been found, I add it to a new array called final sets. Let's take a look at that. Final sets just basically has the time and voltage and angle for all the 9 buses, so all 19 points. It also has a string type, and again, this is going to be used in the Kmeans clustering algorithm. So let's take a look at that. Sorry for the scrolling. So the clustering algorithm is pretty simple. I start off with a Boolean. Finish, this is going to tell me when the algorithm is complete. I initiate the clusters. The clusters are basically going to keep track of the indices in the learning set. So what I made here, final sets. I don't want to move final sets around, so instead I'm just going to keep track of the indices that are in each cluster. And as those change, the learning set is going to stay the same. It's just the clusters that are going to change. To start off, I randomly assign each point to a cluster 1, 2, 3, or 4. And then I calculate the centroids of that cluster. Now, I could just randomly choose centroids to start off with, but I think randomly assigning the clusters gives a better estimate. Once I have the initial clusters, I go through, and the basic algorithm is you have the clusters, you calculate a new centroid, and then you go through each data point and calculate the distance between that data point and all of the 4 centroids, and then assign it to the closest one. So you're assigning it to a new cluster. Once you've assigned all of the data points to a new cluster, you calculate new 4 centroids. And you keep doing this until the centroids don't move between one iteration and another. And this means that the clusters aren't going to change anymore. And that distance is calculated in the method centroid distances. So once the distances doesn't change at all of the centroids remain the same, we set the boolean to true and it exits the while loop. Another thing that's done is I initiate a counter. I don't want it to make the algorithm go too long, so I set the counter as 1000. If it goes that long, too many iterations, and it will exit the while loop. Now, once the clusters have been set, they have to be labeled. So the algorithm for actually choosing the clusters is pretty simple. Deciding the labels required some thinking. Look at that now. So there are 4 labels we can look at: high load, low load, generator disconnected, and line disconnected. Now generator and line disconnected are pretty simple to look at, just looking at the angles. So right here, initiate, print some values to the command window. I also denormalize all of the voltage and angles, and this is so that I can do calculations with the given power values. So what I did before using the max and min, I just do the opposite and get them back to the correct voltage and angle values. And then for each centroid, so there are 4 values, I find the minimum angle of the generator buses, so buses 2 and 3, and the minimum angle, the maximum angle of the remaining buses. For the generator buses, when all of them are connected, those angles should be positive, and when one of them is disconnected, the angle is going to be negative, so that's why I'm looking for the minimum angle. Similar for the line buses. For the remaining buses, when all the lines are connected, the angle should be negative, and when one of them gets disconnected, the angle is going to switch to positive because it becomes inductive. Lastly, I'm looking at the current, total current of all the loads of the buses, the load buses, and I do this by taking the power at the load buses and dividing by the voltage. And I sum those together to find total load current. So, like I said before, finding the generator disconnected and line disconnected clusters is much simpler. So I go through that and do that first. The centroid with the minimum generator angle is the one with the generator disconnected. The centroid with the maximum line angle is the one with the line disconnected. And I keep track of which clusters have been used up. So the remaining 2 clusters are either high load or low load. And I go through those, and simply whichever has the higher load current is the one with the higher load, one with the lower load current is one with the low load. Once that's done, I go through learning list, which is going to be that initial set that I read in, and I add a type to every data point. So this is going to be passed on to KNN, which Kasha will talk about next. Alright, thanks.